Just a quick follow-up here. I tried the approach of raising the idle up parameter on my transmitter to help fix the problem where when I chop the throttle quickly, the copter becomes destabilized. I set the throttle so it bottoms out around 1100. I think if you look here, you'll see it's 1090 is where it bottoms out. And the results were quite good. Let's just take a look at the video real quick. And what I want to show you, first of all, is let's take a look. Here the throttle bottoms out at 1090. Notice that the gyros remain relatively stable as the throttle bottoms out. Here we've got RC command. Yeah, so I bumped the stick here. I noticed there's this little move on the yaw axis here, and as you can see from RC command, that's because I nudged the stick, maybe on purpose, maybe not on purpose, I don't know. But you can see that when I cut the throttle, the gyros are rock solid. And if we look at the motors, we can see that none of the motors are bottoming out. In fact, if we scroll up here, we can find the actual motor values. And we can see that as I move, the motors are very high. And as I drop the throttle, let's just see if I can find the exact lowest point. 1080, 1101, 1090, 1089. Let's see. It's motors, it's the back two motors. So motors 1 and 3. Let's see. Are they, in fact, running a little lower? Yeah, motor 1 specifically is running lower. Huh, interesting. Yeah, so let's look at motor 1. As I drop the throttle, motor 1 bottoms out at 1077, 1078, 1080, 1090, 1100, 1070. Okay, so motor number 1 never bottoms out. You'll remember my min throttle is around 1025 or 1030, I believe it is. Okay, so now with this rapid climb and chop the throttle, my motor's bottoming out around 1070. Do any of the other motors go any lower? 11, 1060 here, 1060, 1090. Yeah, so it looks like they're bottoming around 1060 or 1070. I've got one more example here where I climb out and drop. Let me just show you that one. We can just look at it real quick. And again, pretty solid. Throttle drops. Throttle bottoms out. Notice the motors do a little blipping here, right? The motors kind of move to stabilize at the moment that the throttle drops. And the gyros stay pretty solid until right here I'm moving the yaw stick and stuff. So maybe not much actually. I take that back. So again, I bumped the, I got to work on that. I bumped the yaw just a little bit as I dropped the throttle. That's probably not intentional. But right here, everything is centered out. Pretty good. That's pretty good. And we'll take another look at the motors here and see what they do. 1070, 1060, 1059. Motor 4 is at 1076. Yeah, 1040. 1040. We're getting awfully close to min throttle. 1030. Boom. Motor number 1 hits min throttle. Motor number 1 bottoms out right here. And in fact, maybe that is why we see this destabilization here. Just a small amount of movement on the gyros that is not commanded. Motor number 1 did bottom out. Very interesting. And in fact, it's very interesting that throughout much of the flight, motor number 1 seems to have less, I don't know. Maybe I'm reading too much into that. So motor number 1 just barely bottomed out. But most of the time, the motors are not hitting min throttle. And that's good because that means they're staying within their command authority. So I could tweak this a little bit. I could say that they're bottoming around 1060 in this example. And so I could drop my idle up a little lower. I could make the argument that one motor actually did bottom out here at 1030, and maybe I need to bump it up a little bit. I don't know. Maybe I'll just leave it right where it is. Or maybe I'll wait another day or two until Boris really irons out all any last remaining kinks in air mode, and I'll just upgrade and use air mode instead of idle up and never think about it again. I don't know. But there's the assessment. I showed you a problem in the previous video, and I thought I wanted to show you a little bit of potentially the solution, which seems to be working pretty good. I do want to say one more thing about this. A thing that occurred to me and that might have occurred to you is, why didn't I turn up my min throttle? If I turn up min throttle, that'll cause the motors to spin faster. Won't that have a similar effect to raising the idle up? And the answer is no. No, it will not. I mean, yes, it'll cause the motors to have a faster idle speed, which might seem like the same thing. But remember that the idle up controls how low the throttle stick appears to go. It does not control how low the motors go. So if the PID loop needs to slow a motor down, this throttle is sort of setting the baseline level that gets fed into the mixer, and then the PID loop adds or subtracts from that baseline level. So as I raise the throttle, the motors will spin faster. But some motors may speed up or slow down as needed to tip the copter, pitch it forward, backward, roll it left, right, etc., right? Min throttle is the absolute minimum throttle value below which the motor will never, never, never go. And if the problem here is that I'm running out of authority, the PID loop is slowing the motor down to the point where the motor can't go any slower. If I raise min throttle, I'm actually making that problem worse. I'm giving less, I'm narrowing the authority that the PID loop has to use, and it'll hit that limit faster. So by raising min throttle, I move the minimum throttle that's fed into the mixer further away. Sorry, I said min throttle. By raising the idle up throttle parameter on my transmitter, the diff number on my transmitter, I'm moving the minimum throttle value that the stick will send into the mixer further away from the bottom of the actual limit on the motor's authority. And that's what I want. I do not want to raise min throttle. In fact, if I could lower min throttle, that would be even better without, obviously, without causing the motor to stop spinning. So as you think about tuning your copter, the more authority that you can give to the PID loop, the more control it can have, and the more flexibility you have. Here I have raised my idle up parameter, which causes me not to be able to drop out of the sky as fast as I used to, because I need that idle up to be higher in order to prevent these motors from running out of authority. If there were something I could do to allow me to lower min throttle without causing the motors to stutter and stop spinning, I would get more authority, and I could have this value be lower without running into this problem where the motor bottoms out. But there isn't. 1025, 1030 is where my min throttle is at, and I just don't see any way to get any lower than that. It's not very far off from min command, frankly. Maybe this is an argument for reducing min command, perhaps, and widening the throttle range that the ESC can see. I don't know. I'm not sure that would actually make a difference, because it would increase the resolution on the throttle channel, but it wouldn't actually increase the amount of headroom you have between the point where the motor stops spinning and the bottom of the channel. So anyway, just some thoughts, and probably the solution to this problem, at least until I go to air mode, which is supposedly the new wonderful thing that makes everything great. There you go, and happy flying.